With 11, let's look at possible sections we might find in paper 2. Remember, paper 2, it's made of by measurements, maps, and scales. But of late, what we're going to do, let's look at this. So we have perimeter, radius, conversions, time, the seating plan, general direction, ratios, giving directions. This could be a little bit of what? Instructions. Giving instructions. Oh, giving instructions. Okay. Then we have what we probability is in both paper 1 and paper 2. We have volume, area, scales. Scales will go hand in hand with setting plan or general direction. Then cost calculations. We shall find out. Anyway, let's start with what we have in front of us. Try to make it easy. Or try to understand these terms. Let's try to understand these terms. And when we look at these terms, what do we really need? We are saying, what could perimeter stand for? This we want to know that it's the total distance around a given 2D shape. A given 2D shape, 2 dimensions, simply meaning it has 2 faces only. Radius is half of the diameter. Diameter, we shall say, is twice the what? The radius. That's mathematical, but let's write it in words. Radius is the line from the center of the circle to the end of that very what? That very circle. You understand? Then diameter, we shall say, you can say diameter is the line from one end of the circle, to another end through the center. That's the diameter. The radius starts from the center. The diameter, it's from one end of the circle to the other. This one's the diameter. Whereas the one that starts from half, this is radius, this is diameter. One end of the circle, end of the through the center, and this one starts from the center to the end of the circle. Okay, you should know that. Then, when we look at volume, what is volume? We shall say it's a space taken up by a 3D object. A 3D object or a 3D shape. All I need is a space taken up. If they ask capacity, just say it's a space inside a 3D object or inside an object. Simply meaning it's the amount a certain object can hold. That's capacity. But for the space taken up by the object, that is volume. Then what about area? Area, we shall all say it's what? Surface covered. Surface covered. Anyway, we need to know. Let's look at some simple formulas that we need to remember. We said perimeter, total distance around a given shape. Total distance around a given shape. Diameter, half. Diameter is twice the radius, and radius is half the diameter. So in other words, there's nothing much that we are losing. Anyway, let's look at the formulas. When we look at formulas here, we shall start with that one of perimeter and of different shapes and different faces, mainly rectangles and circles. Anyway, perimeter. Perimeter. Now, perimeter of a rectangle, what will it be? Perimeter of a circle, what will it be? Perimeter of a square, how shall we get it? Now, for a rectangle, we shall always say 2 into L plus B. Whereas for a circle, actually, for a circle, it's not called perimeter, it's called circumference. Circumference, we shall always say 2 pi r, or someone else might use 2 pi d, sorry, pi d, not 2 pi d, pi d. When do you use this? When you're given the diameter. When do you use? When you have the radius. You choose one of them, not both of them. Okay, surface area, sorry, square. How do you get the perimeter of a square? Remember, it has 4 sides equal. So it will only be 4 times the length of that side. That's what it simply means. Now we have another friend of ours called a triangle. We know very well a triangle has 3 sides. So how do we get its perimeter? We shall say side 1 plus side 2 plus side 3. Look at that. That is perimeter. Now, what else do you have to know? The units. The units will remain the way they are. The units will remain the way they are. Okay, having seen that, let's go to our area. How do we get area of a given shape? I'm just giving formulas. So these were formulas for perimeter. Now let's look at formulas for area. Remember I told you area is the space covered by a given material or a given surface. So we shall say area. First and foremost, you have to know the units for area. They will always be squared. Units for area, they will always be squared. But how to get the area of a rectangle? We shall say length times breadth. That's the formula. Then area of a circle, we shall say pi r squared. That's the area of a circle, whereby pi is a constant number. Pi is a constant number, which is 3,142. Always, where you see the symbol pi, you put that number. Then a square. Square, still we have 2 sides, sorry, all sides equal. So we shall say side times side, which becomes side squared. That's a formula for area of a square. A triangle, we shall start with a half, then base, then times what? Half base times height. Half base times height. Here there's a what? A multiplication sign. These are the formulas for perimeter and area. The units, don't forget them. Okay, let's go. I'm still discussing, yeah? Let's look at volume. Volume, now volume, we are talking of the 3D objects. These the 3D objects are formed from different shapes that we know. Okay, so let's go on and we see. The shapes we look at when we look at volume, we look at what we call a cylinder. This looks like a tin, it looks like that. So from there to there, that's the radius. But if they give you throughout, like this means it will be what? Diameter. This means it will be diameter. Then always the height will be this side. So how do we get the volume of a cylinder? We shall always say, by the way, volume equals to base area times the height of that given what? Object. Base area times height of that given object. Now, for the cylinder, what's a base? A base is a circle. And how do you get the area of a circle? It's pi r squared, pi r squared, pi r squared, h. Please, oh, sorry, we don't put 2 unless when there are 2. So this is how we get the volume of a cylinder. Then, the other part that we are supposed to look at is what we call the surface area. Okay? Surface area. But before we look at the surface area, this is what we call the rectangular what? We call it the rectangular prism. This is what we are talking about. So how do we get the volume of this? This one will be so simple. Just say volume of a rectangular prism is L times B times H. That's how we get the volume of the rectangular prism. So we've seen volume. Then there's another part when you look at this 3D objects. Hey, don't forget, volume units are always cubed. Volume units are always what? Cubed. The units for volume, they are to the power of 3. Anyway, let's look at what we call the surface area. Now, surface area is the total area of all faces that make up a 3D object. Right? So when we check here, I will start with the rectangular prism. We have side 1 here. Then we have side 2. We have side 3. All in all, there are 6. However, we are showing you these ones that are opposite, like the main ones. So 2 has another face the other side. That's why we come to. Then face 1, it has another face this side. You see? And face 3, which is the top, it has the bottom. That's why you see, when we shall say surface area of the rectangular prism, we shall say 2 outside L times B plus L times H plus B times H. All the sides are done. So side 2, what do you see? You see L and the height. This is the area of side 2. B times H. B times H, it's this side here. Y, this is the breadth, and this is the height here. So BH, so this is our side 1. And definitely the one on top, where you see this is the length, this is the length, and this is the breadth. So L times B, this one becomes. So the reason why you're multiplying by 2, because there are 6. So you get your answers like that. Okay, what about the surface area of a cylinder? Surface area of a cylinder, for it will be so simple. If you wish, surface area of a cylinder, we shall always say, please don't worry, 2 pi outside, then pi, 2 pi r, open brackets, r plus h. This will be always the formula for surface area of a cylinder. That's if it's closed. But if it's open one side, that means the 2 goes away. Okay, let's try out this question that we see here down. They're telling us to convert the length of the box to centimeters. Now, when you remember converting, it's changing. So meaning you have to remember this. K is to M is to C, then it's to mm. Whereby you start with 1,000, we count second place is 100 and 10. Whenever you're changing from this side, coming this side, here we shall always divide. And as you come from this side, we shall always multiply. So, change the length of the box to centimeters. It's already in millimeters. So we are from millimeters going to centimeters. What are we? We are coming from this side like this. We are following this rule. So what we're going to do, we are going to divide. So it's 1,500 divided by 10. The answer becomes 150 centimeters. Don't forget the units. Okay. Calculate the distance around the rectangular box in centimeters. The distance around. So meaning you move from here, you come there, you come there, then you go the other side, becomes D. You understand? Something like this. You know? So, in other words, we shall use P equals to 2 into L plus B, the distance around. So, meaning we have open brackets 2, then put 5, 1.5, 1,000, 150 plus the 28. You understand? Then you come pick your calculator, do that, and fix it there. Put it inside the calculations. It will become 2 open brackets 150 plus 28. Press equals, which is 300, 355. Don't forget the units. These have become centimeters. Okay, we've just talked about this. Calculate the surface area in centimeters squared. Now, if you're given a formula, please substitute it in without fear or favor. Okay, the way it is 2 open brackets. What's my length? 150. What's my width? I'm having. Please, we are multiplying. We are not adding. We are multiplying. We are multiplying. Then plus, I'm looking at this plus. 2, I open brackets, width, which is this, 28 times the height. The height is 30. That's done. So this is done. This is done. We said 2, open brackets. Length, which is 150 times, what's the height? 30. So it becomes 2. Pick this up, put it in a calculator. 2, open brackets, 100 times 28, close brackets, plus 2, open brackets. But then you can simplify it. So this becomes 8,400. The first one's 8,400 plus 2, open brackets, 28 times 30, 1,680 plus 2, open brackets, 1,000 times 30. We have 9,000. So finally, we are going to add them up. We shall say 8 plus 9. So it's 19,080. 19,080. Don't forget the units. That is it. Surface area of the box. Okay. So we continue. We shall see them as we go on. Yes, we look at such. Look at that. Now here we have 2 options, or we have two items we're talking about. One is cylindrical and the other is rectangular. But they have given us formulas there to deal with. And let's just use them the way we want. We want to learn them. So the question says what? Determine the height of sugar in both types of constants if the constants are filled below the lead. Now, when you look at this story here, you check very well. They said the lead goes 1 centimeter. That means the height is, but then this will be minus that, and the answer becomes what? 12,7. Don't forget the what? The units. This is question number 2.2.1. 3 marks, convert or calculate the volume of the sugar in the cylindrical constants. Now remember they said in the cylindrical. So these are the ones. How do you get the volume of a cylinder? You come here. Oh, it's already given here. So we shall say volume equals to pi r squared, what? H. Ask yourself, where I have the height? Remember now the height is going to be this one because they're saying calculate the volume of the sugar. The sugar that does not add up to the top. So it doesn't fill up to the top. It leaves some space. So this is its height. Then what about the radius? Come here, check. When you check, do you have radius? No, you have diameter. What happens? If you divide the diameter by 2. We divide the diameter by 2. Pick your calculator there. And you get your answers 5, 5, these are centimeters. So now let's go and we substitute in. So we shall say our volume become 3,142. This was the pi times 5, squared, which was r squared, times the height, which we've just seen as 12,7. At this moment, just pick your calculator. You punch them in. 1, 2, 2, 2 times 5,8 squared times 12,7. 1,342. Comma what? Comma 35. Don't forget the units. Volume, the units have to be cubed. Volume, the units have to be cubed. Mm. Mm. All right, let's look at this. And it says, yeah, this is why you need to remember some definitions. You need to match. I'm here looking at this. Let's just guess and we see what we are looking at. It's a table, list of explanations and definitions of the concepts. The definitions are down there, but these are explanations. Okay, so these are definitions. Oh, explanations are definitions of, okay, it's fine. Are symbolic representations of selected characteristics of a place drawn on a flat surface. This could be what? A map. Show the design and dimensions of the outside of the building from a side view. This is what we call it's called an elevation. The elevation map, the elevation design, sorry, not map, the elevation. Okay, a map of small areas such as a town or city. A map of a small area such as a town or a city. This could be a strip map or a street map. A street map, street map. Because a town or a city will always show streets. Street map. Then we say statement describing the chance of an outcome to happen based on given information. This could be prediction. Prediction, predict. Then information about the portfolio of a route as seen from the side. Okay, yeah, this is what we call the strip map. This is a strip map. Okay. The total distance around the boundary. Yeah, this could be circumference or what? Perimeter. Then we are looking at the number of times that something happens. This one we call it what? Call it frequency. The amount of space available to hold something, usually measured in liters. Nothing rather than what? Capacity. Why am I saying capacity? Amount available to hold. Now, and they are making it, especially in liters. So the capacity, how much can it take? How much can it hold? Okay, let's look at that. Oh, wow. Here, you see now, having gone through everything, just come and you substitute now. Please write the question and the letter. So here in this case, it will be 1.1.1, 1.1.2, 1.1.3, 1.1.4, then we have 1.1.5. And we see prediction, we already said it's a D. Elevation map, a map of a small area, such as a street, no. An elevation map is supposed to show the steep slopes and the valleys, anyway. Let's come here and we say, prediction, it's D. Elevation map, there's nothing here about the elevation map. It's just anyway, it's here. Let's take this other one here. C, but it's not that straight. This one, yes, elevation plan. The elevation plan, this one here. Outside of the building, from a side. So it's B. The floor plan is from above. From the side, it's an elevation. So perimeter, we are saying it's the boundary, which is what? F. And capacity, it's the last one, which is H. An elevation map, it's no, what was not clearly explained, but it's fine. Okay, let's look at this other one here. The person's grandmother, turning a 90, she plans to bake some vanilla muffins using the recipe below. In addition to her birthday cake, it takes 20 minutes to bake 12 vanilla muffins at an oven temperature of 400 degrees Fahrenheit. These are the ingredients. These are the ingredients that you need. They're telling us, calculate the milk needed in millimeters, in milliliters. So, first and foremost, look for the milk. Do you have any milk? Yes, it's where? Here. But now it's measured in cups. So what are we going to do? So we need 2 cups. But they want the answer in what? Mils. You come down here, remember, 1 cup is equivalent to, so if 1 cup is equivalent to that, that means 2 cups are equivalent to what? 1,000 mils, which is approximately 1 liter. But the question wants you to have the answer in mils. Okay. Now, what if they asked you, I'm just saying, what if they asked you, how much milk will you need for 60 people or 60 muffins? How much milk will you need for 60 muffins? So we shall say if 12, we need 2 cups. What about 6? Simply meaning cross multiply, this becomes 120 equals to 12 equals to 12 equals to 12. Then just divide through by that. Divide through that, that goes that, and you see. So here we have the answer is 10. The answer becomes 10. Okay, let's look at that. Still under the same, asking us the time it will take, to finish the muffin. If it starts at this, how much time will it take? Remember they said 20 minutes to bake, but they never added us any other time. So what shall we say? If the person began at this much time, we shall just add the 20, and we say 47. So 13 minutes to 9. We are adding because this is the time when she's going. That's the time she's going to spend. Okay, we come to this other question. It says write down the ratio. Now, when it comes to ratios, please do it the way it's supposed to be done. Ratios are write down the ratio of sugar to flour, meaning S is to F. Sugar, where's our sugar here? It's 2 cups. And the flour, it's 4 cups. So simplified form, the same as 1 is to 2. Whenever you have 2 cups of sugar, you need 4 cups of flour. Okay. Hey, this one here, they're telling us convert the 400. Now, look at the formula I've given you. This is another tricky one. That's why you see it's 4 marks. It's another tricky one. So all you have to do, substitute correctly. So what we have are degrees Fahrenheit. We need degrees Celsius. So what are we going to do? They have told us if you have 400, you have this over that times the Celsius plus. So use the mathematics. This one jumps over here. 400 becomes a negative. Minus 32 equals, here you're left with 5C. So I would advise you change this to decimals. 9 divided by, change it to decimals. How do we change it to decimals? It will be 9 divided by 5. You have that answer there, which is 1,8. So simply meaning 4 minus 32, 400 minus 32 you get is 300. 300. This only comes this. 380 equals. Now, if you change this to, because we said it was this, so it will be this much. So divide through by that. Divide through by that. And the answer became 204 degrees Celsius. Okay, let's look at the next part. Time. Yes, when we look at time, what we expect to see under time is to tell us that time is split into what we call the analog, and it has the other side which you call the digital format. Digital format, it's 24-hour system, and this is what we call the 12-hour system. Under analog, this is where we have the AM and we have the PM. Here we have nothing. Please don't do anything there. Okay. What you have to remember again is that we also have what we call, under time we have what we call duration. Duration simply means time taken to accomplish a given activity. For example, if someone starts a given activity at, let's say, 12:48, this is afternoon, then finishes the job at He finishes the job at let's say 5:55. 5:55. This is PM. How do we do this? What we do, first and foremost, duration, how much time have you taken, equal to the end time, the time when they ended, minus start time, when they started. So end time, and before we do this, everything has to be in 24-hour system. So what do we do? This one remains, because it's already what? PM, but this one here, because this one doesn't change, it starts changing at 1. So when we change this to 24-hour system, this one will remain 12. Then here we shall remain with what? We add 12. So it becomes 17:55. So when we come here to look for duration, we shall say 17:55 minus 12:48. Subtract. Now, 55 minus 48, I believe you remain with 13. And this other side you remain with what? 5. So the person has spent 5 hours and 13 minutes. How do you use a calculator? You press the calculator, you say. Don't touch the calculator when the time is still raw. Change it to 24-hour system. So you press 17, then you press this key here. Press the minutes, you press that key. Minus 12, you press that key. 48, you press that key. Press equal, you see. Oh. So we get how much? We have, this is 48. I thought it was 43. 48, the answer here is supposed to be 07. The person has spent 5 hours and 7 minutes. You see how we confirm the answers. Okay. Another thing that you would expect to see on time is to convert. To convert, especially they like minutes and hours. How do we do that? You still use the same key. Let me show you. If someone told you they spent 148 minutes, you want this to become hours and minutes. What do? We divide by 60. When you divide by 60, it will give you a point. Divided by 60. So you have 2,467. These are hours. But we want the answer to have hours and minutes. So of the full hours, we have 2 hours. So what's remaining if you take away the 2? You remain with 0,467. Multiply this by 60. You remain with 28. So here we have 28 what? Minutes. And indeed, because just look at 148, because 2 hours, it has 120 minutes. If you subtract this, okay, 120 minutes. When you subtract here you remain with 2, here you remain with 8, which is this. How do you use your calculator? When you just come here and say 148 divided by 60 equals. So the moment you press and you come and press this, 2 hours, 28 minutes. 2 hours, 28 minutes. That's how we use that key. Okay. That is time, duration, and converting. Okay. We look at this time here, we say the actual distance between Kimberley and Petermaritzburg via N12 and N1 is 805 kilometers. Kathleen traveled from Kimberley to Petermaritzburg to visit a friend. She left Kimberley at 5:45 a.m. and arrived at 2 in Petermaritzburg. She made 2 stops of 30 minutes each along the journey. Now they're telling us, determine the time in hours Kathleen took driving. So here we are driving. Why are we excluding the stop? Because we were not driving. The car was at rest, but time was going. Anyway, they want us to calculate the time in hours. So what we're going to do, we shall say the last time that it was done, it was 14 minus 5, minus. So here you remain with the 0 minus 45. It's impossible to do with borrow. This becomes 60. 60 minus 45, you remain with 15. Then here you remained with the 13. So 13 minus 5, you remain with 8. So this is the time he spent on the road. Minus 30 times 2, which is 1 hour. So we shall come here, subtract 1 hour. So he spent 7 hours and 15 minutes. 15. So you can also do it with the calculator as I showed you. We say 14, press the key, 00, press the key, minus 5, press the key, or 5, press the key, press equals. So you see, we have 8. This is the time that we have here. Look at that time there. Okay, then minus 1, press the key, 0, press the key. The answer becomes 7 hours, 15 minutes. So this is the time she spent on the road. So in most cases they say, I believe B was saying, hence calculate the speed. Now speed, we shall need the distance and the time. So this is already 805,7 divided by. Now in this scenario here, this is a time. We change the minutes to hours. So it will become 7 plus 15 over 60. Which will become 7 plus 15 divided by, which is 7 hours. So we shall come here, it says 7,25. And we get our final answer. So the final answer is what? When we talk about the sitting plan, we shall only expect you to know where someone is seated. People sit in rows. Maybe this is 1, 2, 3. Mm -mm. So here we have 1, 2, 3. If someone is seated here, another one seated here, let's say, by the way, this, let's use this and we see. Let's say this one is called P, QP. Then this is KR. This one is RC. The other one is what? TE. You understand? So what's the position of what? Of RC, QP, KR, TE. This one is what? A1. This is in C1. This one is in B2. This one is in A3. You know, it's more like a grid. Also the grid reference. This is how we shall do it. Of a sitting plan, they might ask you, how will someone move to their desk? You have to describe that. Otherwise, there's nothing much about the sitting plan. How many people are in the city? How many seats are available? You know, when you look at the sitting plan. General direction. General direction. Here we shall use what we call the compass. Then some words will be from and to. Get that? What's the general direction? Then so when we use like compass, we are looking at this famous symbol here. So it's north, east, south, and west. That's how it is. So in between, this becomes northeast. This becomes southeast, southwest, and northwest. This is what we are looking at. Let's say if we have a point here, P, another one it's here. So general direction of K from P. That means you're starting from P, going to K. So that general direction would be north, northeast. And if it comes to P from K, now you're in K, you're coming back to P, which is south, southwest. This one would be the same as K to P. And this one would be K to, P to K. From. That means you're from P, you're heading to K. Let me hope you have understood that. Okay. Ratios. Here just know that we are dividing or sharing, or you can say you compare quantities of the same units. You understand? Same units, for example, stones and cement. This means if actually need 2 buckets of cement, and they tell you here you will have, let's make it 6 or 5. This means if you have 2 buckets of cement, you'll be able to mix 5 buckets of those stones. But then question comes, what if you have 12 buckets? 12 buckets of stones. How much cement would you need? How many buckets of cement would you need? You see now the story has changed a little bit. Do you know what you're going to do? You will ask yourself, if 2 is equivalent to 5, now I have 12. How many buckets? So cross multiply. This will become 5. And this will become 2 times 12. You get 24. Divide by 5. Divide by 5. This goes with that. So how many buckets of... So you see that. You shall say 24 divided by 5. You have 4. So here the answer becomes 4,8 buckets of semen. Probability. Here we said it's a chance something happens. Expression. One, you can express probability as a fraction, but simplified form, or as a decimal, if not as a percentage. As a percentage. Okay? Your answers should lie in between 0 and 1. 0 and 1. If it's percentage, 0 and 100%. Should not go below 0 and should not go beyond 100%. Should not go beyond, sorry, below 0, should not go beyond 1. Okay, we look at this. Use the given scale to determine the distance as the expo. Now, as this one here, it means you measure the distance in with a straight line. Okay, a scale. You know we have 2 types of scales. One is called a number. We have a number or ratio scale. All right, then we have a bar scale. One is the number format and the other is n. So use a given scale to determine the distance. Now, for example, if the scale is 2, usually they start with 1. 1 is to 480,000. And on the map, usually we measure. So if on the map, you imagine you've measured, let's say, 27 millimeters. What will it be in real life? So we shall say 27. But what is it? Cross multiply. Meaning the missing number will be 27 times our. So the answer becomes we have this much. 12,906,000, sorry. These are trillion, eh? No. 129,600,000. Remember, these are millimeters. We want them to become real. What do? We divide by million. Divide by a million. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. So you remain with kilometers. That's what they're saying. Hmm. So here they're telling us you have 2 million. So we divide this by 1 million. This will go with that. 1 0 will go with that, remain with 100. So the distance is 12,9, but kilometers now. Yeah, calculation cost, which we shall end with. Here you might be asked to give money or find out the calculation or the money, how much they spent. For example, if this guy's car takes 5, for every 100, calculate the fuel needed to for. Now take note of that return trip. Imagine you have covered a distance of 800 kilometers. If they say return, you will say times 2. Why? Because the distance was just going, so you need to return. So 800 times 2, we have 1,680, 84. These are kilometers. But the fuel is measured per kilo, per 100. So we divide by 100. So we shall need 16,84 liters. So how much would it be if the cost is 23 rand 17 cents per liter? So what do? You come here, multiply by that, and you get the answer. Sorry. Then here it means this is the distance, ne? So we shall get 6,8 times for every 100 each. It will take what? So supposed to do that. So it needs 94. These are the liters now. How much will it be? We multiply by the price given to us. So that would be the answer.